Alright. We can get started here in a second. Let me just clear my environment up here. Good. All right. Hope everybody's doing good. Excuse me, I'm trying to balance this mic just right. Please feel free to post your Python questions in the thread in Basic Prep. I will take questions as I see them. Let me actually pull up Slack here on my phone. As per is tradition, I forgot to do this ahead of time. Okay. There we are. So if I don't see any questions, I'm just going to be going through the material. Oops, looks like we're... Sorry, let me adjust this audio a little bit. I'm going to turn it down. Looks like the audio is peaking. Check, check, check. Check, 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 check. Okay, that looks better. Check, check, check. Okay. Sorry about that. So we'll just start on the extend method. I think this is where we actually... No, I'm worried that this is not where we left off. Just want to make sure. I think we went through this already. We definitely did. Okay. So let's just start. List functions and methods. Okay. Sorry for that. All right, functions versus methods. So at the end of this, we want to be able to distinguish between functions and methods. So this is kind of, I think the trick here is just learning, well, I guess there's a little syntax involved, but there's a lot of overlap in the roles between functions and methods. They might look a little different. They do similar jobs, and they can be a little confusing to see how they're different. Mostly the way that they're different is methods sort of live along with the whatever data type that they're called on, right? So we have list methods. Let's take a look at our list methods real quick. So we can really quickly determine what all our list methods are by printing out the directory with the dir function, dir, of a list. And we can just pass it any list. I could also give it a list identifier or type specifier. Cool. As per usual, we're going to ignore the dunder methods. For now, we'll just look at the regular named methods. I'm not going to go through all these just to give you, but I'll just give you an example. So certainly, if you're up to speed on the material that we're covering at this point, many or all or most of these, or at least some of these should look familiar, right? Append, especially, because this is probably the method that we use the most. So a method is called with this sort of dot syntax. So let's say I have a list. We'll just create an empty list, and if I want to use a method, I'm going to say list dot, and then we'll name one of these methods. In this case, we'll just do append, and let's just print our list below. And that's going to give us the list that we initialized, which was empty, with hello appended to it, which will make the list not empty. Cool, so now we have a list of hello. Wonderful. So, this method, this append method, is part of the data structure of a list, right? Like, it's a tool that's built in that comes with lists. Functions don't really, so functions live independently. They are their own entities, but they can process certain information, right? So let's take a function, for example, like sum, right? Sum takes a list. Let's do this, and we'll append, instead of this, we'll append a number so we can actually sum it. So we're appending 4 and 6 into our list. So if we print our list, this should be obvious, but we'll have a list with 4 and 6 in it, just to be clear. And then if we take the sum of that list, the sum of that list is going to be 10. Let's see here. If we print out our list after we call the function, the sum function, the value of our list didn't change, right? So the way that Python as a language is built, functions can mutate their inputs. So we could write a function that takes in a list, and then after the function is done running, the list will have a different value. Although none of the functions that are built into Python, and by convention, you should follow this rule that even though functions can mutate their inputs, they never should. Methods sometimes can. Sometimes a method will mutate its inputs. We've talked about mutability, so I won't dive too deep into that right now. I'm trusting that that's a familiar concept at this point. But suffice it to say that methods, by convention, are allowed to mutate their inputs. Methods are like functions. You can see we sort of have, I mean, if this lived outside of the context of a list, it would look like a function. And you can think about it very much like a function. It's a logical process that we have access to the process, but not the actual, definition of it, at least in our program, without going and like modifying the append function in Python, which probably shouldn't do. But it's this interface to a logical process that takes inputs, and we expect something to happen, right? In this case, what we expect to happen is for the append call to change the value of list. This is an example of mutability. So append will alter the list by adding something into it, right? That changes the value of the list. And we pass it an input, just like we would a function. So the difference with append is append by convention is allowed to alter the list that it's called on. Whereas sum by convention is not allowed to alter the list it's called on. So sum returns a value, append alters the list that it's called on. Now the thing is, some methods will have this mutable behavior. Only certain types have mutable methods. Those are known as mutable types. Other types have no mutable methods, and those are known as immutable types, right? So strings and tuples, integers, they have methods too, but they don't have any mutable methods. They don't have any methods that will alter the data like append does, or like many of the mutable methods for lists. So this is something to remember. Functions by convention should only ever return something. They should never cause a side effect or a mutation on their inputs, or on anything else for that matter. Methods by convention are allowed to alter their inputs, but they don't have to. It's not like you're saying, well, we're calling a method, therefore we must be altering the thing we're calling it on. Some methods also return things. So in order to know, you just have to know how that method works. Some methods return something, some methods cause a mutation to the object that they're called on, and some do both. So if we let's do this. Let's append something else, and then I'll give another example of this. List.pop. So the pop method actually, it alters the list by removing something at a given index, and it also returns that thing at a given index. So if I pop the first element, right? So we give it an index. So this list is going to contain 4 at index 0, 6 at index 1, and 8 at index 2, right? So the element at index 1 is going to be 6, the number 6. So if I list.pop element 1, or the element at index 1, we'll just say res for result. Result equals list.pop, and let's just print res, and we'll print list there too. Okay. And let's print list actually before I call pop, just to show that it does change. Okay, so here's our original list after our appends, and here's our list after we popped, and here's the result of the pop. So pop both mutates the list and returns the thing that it removes from the list, that it, mutated the list with. Okay, so that's, I said I wouldn't get into mutability, and look at me go. Cool. So this is just something to remember. Like, methods can return something, which makes them behave a whole lot like functions. But they can also cause a mutation to the objects that they're called on. Now, I know I've kind of said this before, but to be clear, both functions and methods can do each other's job, essentially. They can do essentially the same things. It's just that there's a convention about which roles each one should do. So if you're wanting to create a mutation in an object, you should write a method. If you're wanting to just return a value, you should write a function. My opinion is that in general you want to return values, so I write functions overwhelmingly more than I write methods. Not to say there's never a good case to write a method, but it's just my preference. Okay, cool. Blah, blah, blah. Let's go through this lesson, shall we? We'll just kind of skim through it, jump into the questions, and go from there. Okay. So a function is a sequence of instructions that perform a specific task. Functions are a basic construct of abstraction. Abstraction is a general term to describe a certain set of features that abstract code away. So Python has functions, and classes are also considered an abstraction. So functions are a very simple type of abstraction and allow for more granular processes to be easily reproducible. So by defining a function in a snippet of code, one can utilize the process. Oh, I don't need to read through this. We know how functions work. You write some code, you encapsulate it in a function. When you want to utilize that logic and get the value that it returns, you invoke the function, pass it the necessary inputs that it requires and expects, and you get your result. This is a good resource. It's a great resource. Let me see. Actually, I'll just open it like this. I'm going to paste this in to Slack here. Let me see if I can actually get this to display properly. That looks a little better. We'll just do that for now. Let's see. Unlock this. Can I see if I can get all of this on screen? Do just my browser here. Shrink myself down a little bit. Okay, cool. So here's all the functions built into Python. And you can see there's there's quite a number. Some of these I use all the time. I think some of them I've never used. But this is a great reference. If you're bored, if you're learning Python and you're bored, you're looking for something to do, an interesting challenge, just come to this link and just pick one. You might never use it. You might not understand it. So let's just look at oct. Let's just see what oct does. Convert an integer number into an octal string. Oh. Prefaced with OO. That's interesting. I think that's 0 and then a lowercase o. The result is a valid Python expression. If x is not a Python int object, so x presumably is the input to oct. Yeah, right here. See, it says oct takes in x, right? So it says if x is not a Python int object, if it's not an integer that Python can recognize, it has to define an index method that returns an integer, for example. Okay. So let's just try to use this. So it looks like this is just going to give us print CT. So it looks like I can pass it an integer. Let's just see what 10 is going to be. Oops. Okay, so you can see, yeah, it's prefaced with 0 and O, and that just tells me that it's an octal number, I suppose. So if we look at octal counting, we're going to have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So the integer, the base 10 integer 10 will be 12 in octal, in an octal counting. Cool. To be clear, I'm saying 12, although that's wrong. The name for this number is still 10. You know, it's still the same value. It's just being represented with a 1 and a 2 because we opted into a different base, right? So that's something fun you can do. I'm not sure how often I'm going to use octal. Probably not that often, but it's there, right? So this is something that I would do like when I was first learning. Just come in here and just kind of click on a random one, see if I could understand what was going on, give it an honest go, see if I could figure it out. And sometimes you learn cool stuff. Sometimes you find a new tool that you can use later, or that you're like, oh, I could use this in a thing that I'm currently doing, or whatever. Okay. Syntax for defining a function, we know all about that. Calling a function, looking good. Yep. All right. So let's look at methods. So in Python, everything is considered an object. This is a bit of a I know what's meant by this, but the way this is stated, I think, makes it sound like extremely like everything. It's not quite everything. That's what I'm trying to say, right? Like a function technically is an object. If I print the type of print, right, which is a function, right, we're going to get this class, built-in function or method. As you're learning about objects and object-oriented programming, Python uses the word class as basically a synonym for object. If you're familiar with another object-oriented language, class just basically means object. It's how you create objects is with the class command, right? So if we look at functions themselves, functions actually are considered a type of object, but if we look at like for or something, this is going to be an error. Python doesn't even know what to do with that, right? So I get what they're getting at here, but this is not. I would say this is might be a little misleading. So the way I would think about this, what's meant by everything is everything that you would consider a data type, or having a value or returning value, functions, obviously classes. Yeah. So everything that we would consider a data type would be an object, right? So lists are formal objects. Oops. Lists, integers, strings, floats, dictionaries, etc. Right? So you can think about the types as being objects. So a method is a function that is associated with a specific type of object, a specific data type or a specific object, aka a specific object. And we call the method using the dot notation. So dot notation takes the form, I kind of showed this with Python, right? We name the object, I kind of showed this with lists. So we name the object, you know, if we're doing append list equals a list, let's just call it this list, right? So we'll name the variable that points at the object that we want to append to dot append, right? So that's object name dot method name. In this case, the name of the object would actually be list. That would be the name of the object that this list variable points to, right? So for example, my list.append would be how you append da da da. Okay. An object such as a list needs to be instantiated in order to use the method associated with the object. This is what is meant by instantiated, this line on 39 right here. I made an instance of a list. Just get a little more space down here. So this is called instantiating the object, right? So we need to make a new instance of it, and I can just do that by saying this list equals a list. Okay, so an object such as a list needs to be instantiated in order to use the methods associated with that object. Instantiation simply means to create a new instance of, or to declare. For example, instantiating a list object may look like SUMList equals 1, 2, 3, 4. So that's cool. Okay. All right. There you go. So methods can be thought of as a subset of functions. However, it is in your best interest to differentiate between methods and functions, as there are a few subtle differences between the meanings of these words in Python. Also, you should use the correct vocabulary when communicating with potential employers or coworkers so as to avoid sounding like a novice. This is a good point, right? Like methods and functions have so much overlap in terms of the roles that they play in programming, and it's funny, you know, if you're looking at a method and you call it a function, or vice versa, you call a function a method, people will notice. And then regardless, you know, there's this thing about like when we define a function or a method, in the definition, its inputs, we refer to them as parameters, and when we invoke that function or method, the invocation, we call those inputs arguments. But everybody just uses the word arguments for both, right? Like, and most of us know the correct terminology, but we call, whether we're defining it or calling it, we call it an argument. And you'd be understood if you called everything an argument. So it's kind of funny because there's certain times where as an industry, certain things will become, you know, canon even though they're wrong, and everybody just knows and just says it that way anyways. but then certain things that seem really similar, if they're not differentiated, people will notice. So that's a good point. So one key difference between methods and functions is that a method is implicitly passed the object on which it was called. So that's a good point. That's a really good way of thinking about this. If the method that you're calling, or if the thing that you're calling takes into consideration the value of the thing you're calling it on, then it's a method. I'll really melt your brain right here, right? Let's create a new class. I'm just gonna we'll write our own method. So we'll say class class. Well, I don't want to get too deep into the weeds of this. But if I do def test, and we'll just say, or let's just say sum a b, we'll take an a and b, and we'll return the sum of a and b. Okay, so if I say my class dot sum a b 3 and 4, right? You might think we would call this a method. Oops. Oops. Return sum a. What am I doing? Return a plus b. That's what I meant to do. Okay, so that'll be 7. So this is kind of a funny one, right? So I just made this thing right here. I made a new class called my class, and I wrote this inside of it, and this looks like a function. And in this case, we would refer to it as a function, right? So this is a class that just contains a function, and we would call it a function because I think there would actually be some debate about this. I would call this a function. The reason I would call this a function and not a method is because my class doesn't have a value, right? Like there's no value associated with my class. Maybe we could do something like, let's do another class called my OO class. And for this one, we'll have an init method. We'll take in self. And we'll say val equals, let's do this, self.val. So this will be the value of my OO class. So self.val equals, and we'll just say val. So init will take val. We'll just say val there. Let's have a repr def under repr. We'll take in self, and we'll return self.val. So this will be repr stands for representation. This is how the class will be visually represented. Okay. So if I do my, so we'll say my thingy equals my OO class, and we'll just give it a value of like 5 or something. And in this case, we'll take in self, and we'll do self.val. So we'll call this sum, val, and b. So we'll return, in this case, yeah, let's just return self.val plus b. Oh my gosh, my screen was not being shared. I'm sorry. Jeez. Apologies for that. I should just not switch screens. Okay. So I'm just giving an example here of two different classes. The first example, we were just looking at this my class sum of a and b. So I was just saying, even though we're using dot syntax with this, you know, to call it, I have to specify the class name and say dot and then the function name. You're welcome. I have to say the class name, then dot, and then the function name. I would still call this a function because it doesn't take in the value of my class into consideration. You might think, well, what's, you know, if you look at this little class, like, you might say, well, what is the value? And that's a good question. This little class doesn't have a value. The only thing this is just a container that holds a function right now. It is literally just a container that holds a function. This is an object that just doesn't have, it's kind of incomplete. I do like to use classes like this. It can be useful to just like keep things organized. So I'll do this, but it's not generally what objects are used for. What I'm giving an example of here is a more formal object-oriented class. We have an init and a repr method. These dunder methods have a special purpose. They have, you know, they're predefined special names. Dunder init. If you call something dunder init, it's going to have that special init role. Within the class, right? So init stands for initialize. This method will be called when we invoke or when we instantiate or initialize the class, right? So if I make a new instance of my OO, my object-oriented class right here, and we'll just pass it a value. This could be any value, right? This number 5 is gonna be passed in for val in init right here. Self needs to be the first argument of init, and this actually refers to the class itself, right? So what I'm gonna say is self.val equals my val parameter that I passed in, right? So what self.val does is it says it refers to itself, which is my OO class, and it creates a new property in that class called val, and it sets that equal to the val that I passed in, right? Let's just differentiate between these. We'll say my val, and we'll call this one class val. Class val. Okay. So self.class val equals the my val. All right. So this self.class value, we're going to treat this as the value for my OO class, right? So this is going to persist. Inside this init method, what I've said is I want to create essentially like a variable that is going to exist in this class that's going to persist under the name of self.classVal. So every time I want to use this in my other methods in this class, I can use it inside there. or I can use it via self.classVal. So repr will define how this class is to be visually represented. So I'm just doing something simple. I'm just saying we're going to return self.classVal as the value for repr, the visual representation of this function, or this class, I mean. And then here I'm just making this example method. It's going to take in self, which means the class itself, and it's going to take in just another argument that I'm calling b. So it's called sum of val and b, and it's just going to return self.classVal plus b. So let's just update this. We'll say my OO class. Okay. Let's just do that. So let's just take so I'm going to initialize my class. I'm just going to pass it this number 5 into this my thingy variable. We'll just say, let's just call this thing. This is just going to give us, oh. Did I not do this right? Oh. I think I may need to okay, there we go. I spelled repr wrong. That's what happened. R-E-P-R. So that's going to give us 5, right? I forgot that this needs to be a string. Repr needs to return a string, which we can do with this f string right here. Cool. So sum val. So let's do this thing. So we initialize our class, and then we're going to call our method, and we'll add 4 to the value of the thing, and that's going to be 9, right? So if I print thing, this did not cause a mutation, but it just returned a value. So the reason I would consider this a method is that it takes into consideration the value of the object that it's called on. The reason I wouldn't consider this a method, even though the syntax looks similar, is because really, in every way, this is a function. It takes in arguments. It performs a process only considering the arguments passed in here, and it returns a value. That's what a function does. That's all a function does. The fact that we use the dot syntax is just like, it's a namespace thing, you know. Sum AB does not exist in the global scope. It just happens to exist in this my class. So you can collect functions together like this, but they would still be considered functions. So that's a good, I was giving that long example to just give an example of this sentence here. So one key difference between methods and functions is that a method is implicitly passed the object on which it was called. Let's look at that. Here's our method. So even though we're not passing it the object called thing, even though we're not passing it as an argument here, we can infer that it is being passed. And if we look at the definition, in fact, the first argument, the first parameter that we specify is self. So sum val b, takes in self and b, but when we call it, we only pass it a value for b. It assumes that it's taking in the value of thing here as the value of self. So that's why that works in that way. So since it's considering the value of the thing object, the MyO class object, it's considered a method. Okay. Cool. I'm thinking we can just jump into these challenges. Is the code on the second line a function or a method? That's a method. Append. How do I know it's a method? Well, it does take an argument. I mean, it's obviously a logical process. You know, it performs some logical operation and alters the value, but the giveaway, of course, is that it takes into consideration the current value of the list that we call it on, so that's a method. Okay. Is the code on the second line a function or a method? Map. No dot syntax. Map is a function. True or false, methods are applied to an object. Functions are features that call features called in an object. I think it's kind of worded weird the other way around. Methods are features from within an object, and functions are applied to an object. Cool. Okay. Cool. All right, len and sum. These are extremely useful. They're great. It's kind of funny that they're putting them together. I guess they go together, but len will take in. This is in list functions and methods, and len definitely applies to lists, but not only to lists. Len will take in anything that has a length, and it will return the length as an integer, right? Because a length can't be expressed as a float. You can't have something that's like 3.5 elements long, right? It can only be 3 or 4 elements, right? So let's just make let's do list equals a list with 1, 2, 3, 4, 5, and then we'll print the len of the list. That'll give us the length of the list. Len is a very useful function, one of the ones you use all the time. If you don't know it, definitely here is the moment where you memorize it. Cool. So just to give it some more context here, let's just make and we can say let's have a tuple with Okay, so we have a list with these elements. We have a string with the characters, and we have a tuple with 2 strings and a float. Because why not? Believe it'll work with a set. We'll just turn that into a set. And yeah. I think it'll work with even like a range. Let's see if it'll work with a range. So range, let's say 4 to 15. Cool, so I've got 1, 2, 3, 4, 5. Set expected 1 argument, that's my bad. We'll just make a set of a list there. Okay. Cool, so if we look at this, we have the length of our list is 5 because we have 1, 2, 3, 4, 5 elements. The length of our string is 11 because we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 elements. The length of our tuple and our set is 3 because 3 elements, and then the length of our range is 9 because range 6 to 15 covers 9 places. Okay, so len has a broad spectrum of types that it can operate on. So anything that you would think of as having a length, you can use len with. But we'll focus on its role with lists for now. Sum, this is an interesting one. This is a good one. So sum will take in a list of integer or a list of numbers. It doesn't have to be integers. It can be a mix of integers and floats or integers or whatever. Just as long as they're numbers, something that it can sum, and it will return the sum of that. So the sum of 1 plus 2 plus 3 plus 4 plus 5 is, oops, of course I didn't print it. I have a stray, oops, that's what it is. Is going to be 15. So 1 plus 2 is 3, plus 3 is 6, plus 4 is 10, plus 5 is 15. If we did 6, we'd get 21. If we did, let's just say 3.7, we get 24.7. Cool. Okay, so what if our list has a string in it? So this says type error unsupported operand type S for plus between float and stir, and it's going to point at line 77 where we called sum. Might even show us some of the internals of sum here. Nope, it's not this time. Alas. Okay. What this is telling us is that sum will give you the sum of the elements in a list, but all of those elements need to be things that can be summed, right? So we can't give it another list or a string or whatever. Let's just try this. List equals, because we can concatenate 2 strings. I never thought to try this, but I wonder if we did hi and world, Wold, hi and world. I wonder if that's going to do it. Nope, it hates it. So it's only going to do numbers, even though strings can be concatenated. Sum's not going to concatenate a list of strings for you. It wants to see numbers. So just remember that the input to sum has to be a list of numeric values. By the end of this lesson, we'll apply the len and the sum function. Pretty straightforward. Yes. Very useful functions indeed, these. I'm thinking these are pretty good here. Okay, cool. So given the following list, enter its length. So think about this. A list of lists is a list with what in it? What would be the length of this? You might look at this and you might say, well, we have a list and we've got 1, 2, 3, 4, 5, 6 numbers in it. But the length of this wouldn't be 6. And that's because this list of lists has 2 lists in it, right? So the length of this outer list is just 2, right? We wouldn't factor in the lengths of the inner lists. Yeah, exactly. All right, so the list consists of 2 nested lists, right? Given the following code, what will get printed to the console? Sum? Well, I don't want to do that in my head, even though I probably should. So, you know, I'm going to print it out. By the way, if you see code that you can run it. I personally do not consider it cheating. That's how you know, that's called using programming to help you. Use the language to your advantage. All right, len and sum. Given this list of daily high temperatures, calculate the average high for this week. Oh, this is great. So how can we calculate an average? Presuming that many of you know already. Certainly if you're in premium prep, I suppose you would know, but if not, that's okay. So if you don't know, the way I remembered it when I was learning is sum over num, right? Where num is the length of the collection, right? So it's the sum of the collection over the num of the collection. So let's do the mean equals sum of daily temps, the integer that this returned, or the num, not necessarily integer, over the len. Why is there a 0 here? The len of daily temps. Print mean. $58.5. You're trying to calculate the mean. Use sum and len functions to do this. Give an exact answer that appears when you calculate the answer in Python. Cool. Just to be clear, sum and len are very useful. Don't forget them. Sorted and reversed functions. So by the end of this lesson, you'll be able to apply the sorted function and apply the reversed function. So let's get some test data. Let's say list equals list I like tomatoes. Okay. Sorted list. Let's just look at these. So sorted and list, or excuse me, sorted and reversed. Oh, sorted is I like tomatoes. Dang. I don't like tomatoes? What? Oh. It's like I had to pick a phrase that is already out in alphabetical order cuz you know, of course I did. Lexicographical order. So I was like, wait, I definitely comes after D, but since it's capital I, all the capitals are going to go first. That's just how it works. So when you sort a list of strings, they're going to sort in what I just said, lexicographical order. So lexicographical order you can think of as a kind of superset of alphabetical, right? So we can actually use sorted directly on strings, but I think let me just actually do this. Print. We'll do a string of. I'm just going to do all my characters here in the order that they appear. I missed an O. There we go. And then we'll do all the capitals as well. Cool. So I'm just going to copy this. Do this here, and we'll just do dot split. Oops. And oh, excuse me, I actually don't want to do split. I want to do the list function. I will just convert this to a list. And we'll copy this. Okay. So we have this weird out of order list. QWFP, GJL, etc. So if I sort this list, so notice I get my capitals in alphabetical order, followed by my lowercase letters in alphabetical order. Yeah, so that's something to remember. We can also sort a list of numbers, and they're going to sort numerically. So let's do just override list with a list of cool. We'll print the sorted version of that list as well. Notice that the sorted function, since it's a function, it doesn't alter the list. So if we print it again, we'll have the list in the original order. Cool. Looks like we have a question coming in, so I'm going to take a look at this. Is it possible to get assistance with the integer accumulators challenge 3? Sure, we can take a look at that. Integer accumulators challenge 3. All right. Let's just look at this. So by the end of this lesson, you'll be able to implement an integer accumulator, read and understand code which implements an integer accumulator pattern. Good. Oops, excuse me. Sorry for the scrolling around. Sum up only odd integers from mixed data using an accumulator variable. Okay. So we have our elements here. So let's say, so this says only the odd integers. So I'm going to do, so the first thing is we have this this data. So the first mission is to just be able to acquire each element in a each element that we want and isolate it, right? So we'll just start off simple. We'll say for element in mixed data. Let's just print element. I'm all used to working out of my terminal here. I was like, where did this come from? That's from this mixed data. I was like, what? Is my computer talking to me? Okay. So we have 15, 9, 21, hello, etc. Right? So you can see we have multiple different types here. If I printed the type, let's just print the type of each element. We have ints and strings and some bools, or one bool, and we have a float. We have a variety of types. So let's look at the problem statement. It says sum up only the odd integers. Okay. Only odd integers. Well, what makes an odd integer? It's going to be, for one thing, it has to be an integer. So we'll say if type L equals int, print L, and let's see if that gets rid of our floats and strings and such. Those all look like integers to me. All right, cool. So now let's add another condition to make sure it's odd. So we'll say if L mod 2 equals 1, or we'll just say not equals 0. I know we could say equals 1, but I'll do not equals 0. So if it's not equal to 0, then we'll print L, and then we'll look at those and see if those are odd numbers. 9, 21, 35, 15, 3, and 9. Excellent. That looks like all odd numbers. So we want to accumulate those. Let's see what this says again. Sum up only the odd integers from mixed data using the accumulator variable called odd sum. So we'll say odd sum equals, this is an integer accumulator, so presumably we want it to be an integer. Odd sum plus equals L. Not printing anything. Why am I running my code? Print odd sum. Good. So we'll let that run. We'll see what we get. We get 92. I don't know. That seems feasible. It seems like a reasonable result to get from this. See if it works. Yay. All right. So let's see. This is their solution. I think it's exactly my solution. For val in mixed data, if instance val int, or if is instance val int. This is a different way to do the check. I've been told recently that you're supposed to use isInstance instead of type. I don't, because I don't like it. I like to use type. Just getting the type of something and checking if it's equal to whatever type you're trying to check is, I don't know, I find it really easy. And then it's saying if valmod2 is equal to 1, odd sum plus equals val. So a little bit different, a little bit slightly different, but basically the same idea, just a different implementation. We could clean this up a little bit, and we could say and. We'll just do both of those conditions in one go here. And then we can unnest our, notice how odd sum is nested in here twice. Or it's not nested in there twice. It's nested 2 layers deep, right? But we can unnest it 1 layer by just doing both conditions in one line here. And that'll work as well. Cool. Cool. Oh, I'm sorry, I didn't see the second part of your question. In examples, they reference the isInstance function, but thought it might be possible to solve with some method. Not sure because we haven't been able to solve with even integers. Yeah, so sorry about that. What isInstance does is it replaces this type checking part. You want to do the type check because you need to put the element over 2. You need to divide the element by 2 and check if it's not equal to 0. Yeah. So isInstance and type have the same usage in this case. I would say type has a broader usage. I mean, I don't know. Like, I look at isInstance. I think it was recently. I think it was a function that was fairly recently added. I want to say as of Python 3.7 or 3.8. I might be wrong about that, but that was my understanding. That might be inaccurate, but that was my understanding that fairly recently isInstance was added. And I do not see a single reason why that function should exist. I think it was to make type checking like this more semantic, so you're not using a double equals. But to me, this reads so clearly. If the type of the element is equal to an integer, it's so boneheadedly straightforward. So I don't know what they were trying to improve. I don't know, but the folks who develop Python are pretty smart, and in general I really agree with their design decisions, but sometimes I'm not sure what they were thinking. But maybe they have some other reason. There is a weird case also with isInstance, and I'm trying to remember what it was. I think it's I think if you do, let's check this out. Let's check this out a little bit. Let's explore isInstance. I think I remember how to recreate this. So if I say the type of true equals to int, and we'll do if, or we'll do isInstance true int. I think there's a discrepancy. Yeah, so the type of true is a Boolean. Is a Boolean equal to an integer? to my mind, no. A Boolean is not equal to an integer. I mean, that seems fairly straightforward. The way that isInstance is written, if you're checking the type of something and the type of the thing that you're checking happens to be a Boolean, and one of the things you're checking happens to be an integer, isInstance will consider this case true. To me, this is like, why does this function exist, right? Like if I was writing a condition and I was checking the type of a Boolean and I wanted to like include a Boolean as a valid like signal to tell me that I should do something, right? If that was something I wanted to be true, I can make a list and check from a list of types and check for membership. So I can say if the type of true, which is Boolean, is a member of the list, and this list will contain type specifiers, I can say int and bool. Again, this seems like really straightforward code. I'm not sure, isInstance can do something similar where you can have, I don't know, stir. Whoops. I think this will work. isInstance. Okay. Is it like this? Oh, it has to be a tuple. Weird. Okay, so isInstance can take a tuple and it'll check every element in that tuple, but we could use a tuple here if we wanted to like keep it uniform. I guess we could check for membership in a tuple using type or a list using type. So again, I am not sold on the use case for isInstance, but I think I've also made that clear, and I'm getting into that thing where I'm realizing that I'm repeating myself, and I think y'all could probably get it. Cool. So yeah, I would just say next time you see isInstance, just rewrite it in your mind as type. I wouldn't even bother learning isInstance. I'd never use it. I've never found a good use case for it. If that wasn't obvious. Cool. All right. Yeah. I think we've got about 10 minutes left, so let me see if we can wrap up. See if we can wrap up sorted. Unless somebody else has a question or a follow-up question to the one we just went over. Maybe I want to do more on integer accumulators. I think we're good. Okay. I'll just finish sorted in reverse unless somebody has another question. You are welcome. I'm glad that was interesting. Glad you found it interesting. Okay. Sorted and reversed. Oh, okay, let's come back up here. That was the thing that I just did. This is the thing. Okay. So it's just showing sorted. So we can see that sorted is a function. It takes in an argument, returns a value. It does not alter the argument that was passed to it, because no built-in function in Python ever does that, or likely ever will. Hopefully, no function in Python will ever built-in function will ever mutate its inputs. And hopefully all the functions that you write and deal with won't also mutate their inputs, although I've seen some pretty wacky code out there. So sorted returns the sorted version of the list. It does return a different list. We talked about, for those of you who are wondering if it's the same ID, it's a different ID. If it were the same ID, that would be considered a mutation of the list. So notice the order that it sorts in. I was just going to show this. Let's just sprinkle in some numbers in here. That should be fine. Let's see where it puts those numbers. So it looks like I get numbers first, then capital letters, then lowercase letters. We could even let's throw in some special characters. So let's do exclamation point and that symbol, and let's do a closing curly bracket. Let's see where it puts those. So it looks like you get exclamation point up front, and then I get numbers. Where to put my at? Then I get my at symbol, which is kind of, I was not expecting that. I thought it would group those together. And then it looks like I get my closing curly bracket at the end. So special characters can kind of be strewn throughout. But notice how it's not going to put it in the middle. It's going to put it like between numbers and characters somewhere. It's not going to like put it in the middle of capital characters or something, or capital letters or something like that. So this is, you can experiment with this, how exactly sort works, but the ordering that it uses is called lexicographical order, for whatever that's worth, I guess. Oh, yeah. And we can sort strings and numbers. Let's try to sort numbers and strings. So if we have numbers, I mean, these are sorted, like this list here. Let's actually do this. Stir list, and let's call this num list. So if I do like a num stir list, it'd be a list with a string and a number. And if let's say I try to sort that, you probably see where I'm going with this. I think the tone of my voice has given it away. We are not going to be able to do that, right? So type error, it says less than operator not supported between instances of int and string. This is just complaining it doesn't know how to sort an actual int with a string. You might say, well, you know, up here it's sorted ints and strings. It didn't. It sorted numerical characters, right? Where is it? So like 2 is a number character. It is not an int, right? This 2 is not an integer. It is the character 2. It is the string character 2. So it knows how to do that. So maybe it can sort string characters of numbers, like digit characters, and actual literal integers. So this is going to be the same deal, even though the string 5 and the integer 4 are both, the string 5 is a digit character. Python still is not going to make that inference for you. It does not know how to sort strings with numbers. So you have to make sure that the contents of the list, the types of the contents of the list are homogeneous, right? It's other all the types are all the objects in the list are of the same type. That's what I'm trying to say. Cool. Let's just call this other list. I think it's going to do false and then true. False, false, true, true. Cool. So we could sort a list of booleans too. So you can sort whatever. It's just that they have to be of the same type, or of compatible type, right? Like we could sort a we could sort ints and floats because they're compatible. Oops. So we have to have valid code. So when it sorts that list of numbers, we have 2, 3, 5, 7.3, 8, 8.0, and 32. Cool. That's sorted. That's the sorted function. Reversed works a little differently. So actually I'll just copy this code. So if I say stir list, if I want to reverse this, let's work with something. Well, no, this will be fine. We'll print this. Okay, you may ask yourself. No, I'm not gonna sing that song. But you may ask yourself, what will reversed return? You probably won't ask yourself because you'll think, that's just going to give me a reverse version of that list. Nope. It returns a list reverse iterator object, and this is the address. So this is not, reversed is meant for when you want to write a for loop for I in range, or excuse me, for I in reversed string list. It's optimized for this. It doesn't just instantiate the whole list and spit out a whole thing. There's just times where you want to traverse a list in reversed order, and reversed is optimized for that. We'll just pass, actually. Actually, we'll break. If we do want reversed to give us a list back, oops, we can say print list reversed. So we can, like some of you may know this about range, right? We can take a range and pass it to the list function, list function, and we'll get a list of that range, of the elements in that range. We'll get the same thing if we cast the reversed iterator object as a list. So notice we get mkbvcxz, and that's this string list in reverse. So mkbvcxz9, etc. Cool. In general, if I want a reverse, if I want a list to be reversed, like if I just want to quickly reverse a list, or I want the full list out, I'm not going to write all this code. I'll usually just do a slice. So remember, when you're slicing, you have these 3 sections in a slice, right? So it's like you're indexing, but you're not just getting a single element. You're getting a range or a sub collection, a subsequence of elements. And there are 3 things that you can specify in your slice. The first section. So we have these 3 sections. The first section is your start, the index at which you want to start the slice. If you leave it empty, it's going to assume 0. The second section, which is your stop, that's the index where you want to stop your slice. If you leave it empty, it's going to assume that you want to stop, you want to go all the way to the end of the list and include the last element. And then your step, that's the third section. That's the step interval. It's the interval to use for every step in the iteration. So if I gave it 2, it would be every other item. If you leave it blank, it's going to assume that you want a step of 1. And that's positive 1. So what happens if we give it negative 1? If we give it negative 1, it's going to take steps of negative 1, meaning instead of doing positive 1 from left to right, it's going to take steps in negative increments, meaning from right to left. So it'll actually start at the end and go backwards, and it's a de facto reverse. So this is generally, if I want a list to be reversed, this is generally how I'll do it. So that's string list sub : ::(-1). It's kind of funky looking syntax, but if you know how slicing works, it just comes very naturally. Remember, just start, stop, step, negative steps go in the opposite direction. And it's just a little, I don't know, I find it a little cleaner than reversing like this. If I have, let's say I have a really big list or something and I want to optimize it a little bit, I don't want to like just arbitrarily duplicate that giant list in my memory. Line 129 arbitrarily duplicates this list in my memory, so now there are 2 lists with the same data. One is in the opposite order of the other one, so that I've like doubled my memory model. In general, I think people look at that kind of problem and think it's more serious than it is. In this case, like, what is this? I doubt this is even a kilobyte of information. Like, who cares if I double it, right? And this is, you know, I don't know. Well, I guess, yeah, you get bigger data structures for sure, but this data structure could get a whole lot larger before I would have to really worry about doubling it being a problem in my program's memory model, you know, before that, you know, we have a long way to go before it would be like a significant use of resources to double the size of this list, right? But if you are trying to save memory, you want to optimize things a little bit, you can use reversed, and that'll give you a generator over the list. What that does is this just remembers the last thing it returned, and then it just returns the next element from the back of that list. So it's more memory efficient. If you need that, it's a good tool for that. You very well may never actually need that, though. Well, I don't know. I say that, but anywho, that's the reversed function in a nutshell. All right. I'm thinking I'm going to just do these challenges and we'll wrap things up. So, first challenge, given the following code, what would print to the console? So we have our list, we sort our list, we print our list. So that's going to be 0, 1, 3, 4, 5, 9. Be a list of 0, 1, 3, 4, 5, 9. Let's just format this correctly. I don't know. I should check to see if it... Given the following code, what would print to the console? Probably did something wrong. Oh, it got me. I got, y'all. I totally got. Look at that. Alright, I got tricked. I admit it. Defeat. You win this round. Tricky function. I give problems like this. I think I gave problems like this today. I think I pulled this trick on y'all but moments ago, and I got by it. Okay. Whatever. So, calling the function, pretty sure I just said this minutes ago, calling the function sorted on the list does not alter the list. Here we get the sorted version of the list. We don't do anything with it, and then we just print out the regular list. Okay. Given the following code, what prints to the console? We have our list 549310, and then we print a list of our reversed we print the reverse version of the list and we cast it as a list, so we're going to get the whole thing. And we do actually print it out this time, so that actually will be reversed. So we'll say I'm going to go from right to left. So that's 0, 1, 3, 9, 4, 5. So 0, 1, 3, 9, 4, 5. Yay, I did it. Did I? Nope. Okay. Let's just do this one real quick. In the code cell below, complete the following. Sort the list. Sort the list sorted in stored. Oh my gosh. Sort the list stored in random list and save it in a variable called sorted list. Okay. Cool. reverse the list stored in backwards list, stored in a variable called forwards list. Forward list. Okay. Forward list equals list backwards list, sort, then reverse the list stored in all scrambled up, and store it in a list called unscrambled. Equals let's just do this. And we'll do sorted. So sorted, I believe I don't think we'll need to cast reversed to a list, because sorted will take in a pretty wide variety of things. You can actually also pass a string or a tuple, I think a set to sorted. Yeah, you can definitely pass a set to sorted. You can pass a range to sorted. You can pass all sorts of things that aren't lists, but it always spits out a list. So we don't need to cast it as a list, cast reversed as a list before we pass it to sorted. I think we should be able to just pass reversed to sorted directly. We'll see if it works. I got an error. Assertion error. Which, so unscrambled. So let's see. So that is the list that I was just talking about. So let's see. It's got to be something. Oh, wait a second. Sort and then reversed. Oh. Okay, so we want to sort it first. Then we want the reversed version of that. You know what? That makes way more sense. Sorted, and I'm just going to do my thing. ::, -1, we'll just do it that way. That should work. And it does. Cool. Alternatively, we could do say, oh no, come on. And that should work as well. So either one of these will work. I prefer my way, so I'm going to do it my way. Cool. All right. I think that will conclude study hall for today. I had a good time. I always enjoy doing study halls. Thanks for the question today. I hope this was engaging. I hope everybody's liking this format. Do please feel free to reach out on Slack if you want to schedule mentoring. I have a lot of availability in my calendar at the moment, and I'm available for, usually I'll do like 1 hour mentoring sessions. If you're in premium prep, just hit me up. Even if you're not in premium prep, even if you're in basic prep, I'm willing to meet with people. So yeah, definitely just hit me up on Slack. If you're on our Galvanize Slack channels, if you're not, then go to our website and you can sign up there and sign up for our basic prep. And that'll give you access to the Slack channel where you can find me, where you can reach out to me directly. if you want to do that. I am open to feedback, whether it's good or bad. Let me know. I mean to improve these and make these as good as they can be. And I know there are some rough spots. I know the resolution is low. That's something I think that just is sort of a limitation of the computer I'm working on right now. I will be upgrading my machine within the next few months to hopefully ameliorate that. So just a heads up on that. Yeah, also any other improvements that you can think of, suggestions, other questions, whatever you need, I'm here. So that being said, I will bid you adieu. And sometimes I hear myself speak and I wonder why. Anyways, have a lovely rest of your evening. And for those of you in Premium Prep, Tovio and I will be co-teaching the final class of this go-around this evening. So maybe I'll see you there. Have a good one. Bye-bye.